Our experiment determined the average rate of recovery of teenage heart rates following 1 minute 30 seconds of exercise.
The recovery of heart rate goes through two periods of reduction. The first period is when the heart rate declines immediately after exercise because of an increase of cardiac vagal activity. This activity is the activity in the parasympathetic nervous system that controls the cardiovascular system. This causes a calming effect in the heart muscles, therefore reducing the heart rate. The second period of recovery occurs with a gradual decline of heart rate for several minutes after exercise is stopped. This happens because the cardiac vagal activity increases too much, so the body sends out cardiac vagal inhibitors to ensure the heart muscles do not relax past a healthy level. This inhibitor causes the effect of the cardiac vagal activity to decrease, which slows the heart rate at a more gradual pace. Several studies have shown that females have a lower heart rate following exercise. This shows that they will have a higher rate of heart rate recovery after this exercise.
The gender of the subjects will not affect the average time it takes for heart rates to return to the resting rate after 1 minute and 30 seconds of exercise. The independent variable of this experiment was the gender of subjects. 15 high school age females were chosen and 15 males of the same age. The dependent variable was the duration of time that it took for the heart rate to recover to the resting rate. The first step of the procedure was to take the heart rate before the step exercise to acquire the resting heart rate, and we did that for 6 seconds and then multiplied it by 10. The next step was to make the participants do 1 minute and 30 seconds of steps to 120 beats per minute at a metronome sound. After the exercise, the next step was to take the heart rate immediately after the exercise to acquire the first heart rate. The next step we took was we recorded the heart rate on the data table, and then we repeated the heart rate recording every 30 seconds until the individual was back to their normal resting heart rate.
As shown by the graph, the female subjects had a faster rate of heart rate recovery. The females had an average heart rate recovery rate of about 1.58 beats per minute over second, whereas males were about 0.820 beats per minute over second.
The standard deviation for men was 0.8205. For women, it was 1.588. That is a variation from the average shown in the heart rates.
A factor affecting the amount of error in this experiment was the physical fitness of participant. If a certain male or female was more cardiovascular fit, the heart rate recovery would have been faster than normal, hindering the average. Also, despite the metronome pace given during experimentation, each subject could have been something faster or slower compared to others, which would have caused their heart rate to elevate more or less than the others and have an altered recovery rate. Timing of the heart rate would also affect results. If one timing of the rate was longer, more heartbeats would be recorded, and that would cause someone to go longer until resting heart rate was reached, again affecting the averages.
Our hypothesis was rejected due to there being a 99.95% chance that we were wrong, which means there is a significant difference between the genders in heart rate recovery after exercise.